This video, I'm going to continue just going through a problem in the last minute review part 2 packet handout, and looking at number 4 here. This is a snippet of a problem just involving MVT, but it's interesting enough where I want to kind of go through it. Functions f, g, and h are twice differentiable, so again, smooth curve, no sharp turns, and at least x squared degree polynomial. We have g of 5 equals h of 1 is equal to 1. Okay. The line linear equation here is tangent to both the graph of g at x equals 5 and the graph of h at x equals 5. So even though g and h are curved functions, they're going to share the same slope as this line at that point. Okay, so this line is going to be tangent to both those graphs at that point. Okay, so this part, just want to go over these specific parts that I took from a problem. It says, let m equal to the derivative of this definite integral of g of t. Write an expression for m prime. So if we want to find m prime, we have to go through second theorem. Okay. Well, but first let's find m of x. All right, this is asking for m prime, but let's first clean up this m of x equation. So to clean up this m of x equation, we have to apply second theorem. So second theorem, because we have derivative and integral applied to the same function. Again, to remind us of second theorem, what we do is we know these two operations cancel out. We just have to deal with this upper bound. So plug the upper bound variable in for the variable of the expression, so f of p of x. Then we multiply it by the upper bound's derivative, so times p prime. So when we do that, we plug 2x in for the t, and then we also multiply it by the 2x's derivative, which is times 2. So we get 2 times g of 2x. So now we have a cleaned up version for m of x. It's asking for an expression for m prime, so to find m prime, we have to find the derivative one level down. So to find the derivative of this expression, this cleaned up expression, we need to recognize that the 2 is a coefficient. It's just going to tag along, so no need for product rule. But this g of 2x, there's a function within a function, right? We have something more than just an x inside that g function. So we have to go through chain rule. So chain rule says take the outside's derivative, multiply by the inside's derivative. So the 2 is going to stay, it's a coefficient. The derivative for g of u is going to be g prime of u times u prime, so times the 2x's derivative. Okay. Push that 2 out in front, we get 4 g prime of 2x. So now that we have our derivative equation, we're now going to use this to evaluate m prime of 2.5. So we'll plug 2.5 in for x, and we get 4 times g prime of 2 times 2.5. 2 times 2.5 is 5. So g prime of 5, we have to gather some information to figure out what g prime of 5 is. Well, we don't have an equation for g of x, but we do know that at 5, this graph is going to share the same slope as this line. And if this is a line that has a consistent slope all the way through, if I rewrite this in slope-intercept form, it's easy for me to identify that, okay, this graph is, this line is always going to have a slope of -5/3. So this constant slope must represent the slope of this g graph at 5, because the problem tells us that this line is tangent to the graph of g at 5. So we can replace g prime of 5 with -5/3. That's the slope of this line. So now 4 times -5/3 is just -20/3. All right, so that's this first part. Second part is let m of x equal to the derivative of the definite integral. So the same m of x equation defined from part D. It is known that c is equal to 2.5 satisfies the conclusion of mean value theorem between the interval from 1 to 4. So if we think about mean value theorem, this is a hint that's going to tell us what the next step is going to be. So let's recall mean value theorem. Mean value theorem says if I find the slope between the endpoints, that slope is going to be guaranteed somewhere on the curve itself. So f prime of c is equal to f of b minus f of a over b minus a. So let's adapt this for m prime of c. All right. We're not dealing with function f now. We're dealing with function m. So let's rewrite our original mean value theorem, adapt it for this problem. So m prime of c is equal to m of b minus m of a over b minus a. All right. They're telling us mean value theorem applies for m of x. So I'm going to start with this and then see what we can fill in. All right. We know that the c value is 2.5, so we can plug that 2.5 in for the c here. We know our endpoints are a and b. So our a and b value, 1 and 4. So I'll do m of 4 minus m of a over 4 minus 1. So we know that this problem is trying to get the student to write this out. Okay. So maybe we can make some progress here. All right. What's m of 4 and what's m of 1? Well, we know that we have a formula that we've gathered at the end of part D, is that we do have a formula for m of x, right, which is 2 times g of x. This is going to help us connect to something that we can use. So now we're going to plug in, let's define m of 4 and m of a. Let's convert this to be in terms of g, because eventually, in the end, we're trying to produce something that is using g functions. So this is going to help us move us towards where we need to be. So from part D, we're going to transfer that information. So m of 4 means that I'm going to plug 4 in for the x of my expression. So 2g times 2 times 4, that's 2g of 8 minus 2g of 2. Okay, all over 4 minus 1. So now, if we clean this up here, we're now moving towards something that the problem is trying to ask us to find. So g of 8 minus 2g of 2, we're getting closer, right? M prime of 2.5, right? M prime 2.5, we do have that information at the end of D, right? We found that out, so we can make that substitution in here. And now we should be able to see where we're headed towards, right? We can cancel out the 3's. We're left with negative 20 is equal to 2g8 minus 2g of 2. We can factor the 2 out. And then once we factor the 2 out, we can, we're getting closer. So if we divide the 2 over to the left side, we can isolate this g of 8 minus g of 2, which is what the problem is trying to ask us to find. So once we get g of 8 minus g of 2 equals negative 10, then there's our answer.